Okay, so this is going to be the second lesson for our fifth unit. And again, that unit is going to be scatter plots and data analysis over here. And this is going to be our second lesson. So you should have handout number 2. Don't forget, if you haven't stopped to get the handout from me, make sure that you ask me in class to go ahead and give you the packet so that you can fill out your notes. If you are absent and you were wanting to do it at home, you can go into your OneNote. You can go into the Content Library tab, click on Unit 5. You'll click on the Class Notes section, and then this is October 31st, MTM Constructing Scatter Plots, and then the homework will be 1031 MTM Constructing Scatter Plots, but over to the side it'll say Homework 2 instead of handouts. Okay, so we're going to go ahead and get started looking at this lesson. And we're going to just jump right into it. It says, Jared's basketball team stood at various distances from the basketball goal and counted the number of baskets they were able to make in 30 seconds. The distance each person stood from the goal and the number of baskets made is shown in the table. So Jared stood 14 feet away from the goal and he made 4 baskets. Tyrell 25 feet away and he made 6 baskets, and so on and so forth for the rest of the teammates. And then it says, use the data in this table to make a scatter plot. Again, last lesson we talked about scatter plots. That's where, kind of like when you go out and you scatter seeds and things like that, the data is not in a straight line. It can be linear. It can have a linear trend or a linear association, but it's not going to be a nice, perfect straight line. The data and the points are going to be kind of scattered throughout the graph. So then we're going to answer the questions that follow. So we're going to start plotting it. Your axis on your graph have not been labeled yet, and I went ahead and took the liberty of labeling mine before I started recording. I counted this x-axis down here by 2s. Okay, and I'll go ahead and label my x and my y-axis. That way you can see them. Again, the x is counting by 2s, the y is counting by 1. So remember, this horizontal axis is your x-axis, the vertical axis is your y-axis. And the reason that I put the y-axis counting by 1s going up to 14 is because the output here, the y's, the amount that they scored, the highest one is 14. So I know I'm not going to have to plot any data that's larger than 14. Same thing for my x-axis. I realized that our data was a little bit larger. Tim got 28 foot away and still scored about 5 goals. So I went ahead and counted by 2 so that we could plot all the way up to Tim's 28 feet. So again, go ahead and pause the video and create your graph, and I'll give you a second to do that. Okay, awesome. So now what we're going to do is we're just going to start graphing it. So it said Jared was at 14 feet, which is a x value. So we're going to go over 14 feet on the x. Remember, you've got to get on your elevator before you can go up and down when you're graphing points. So we're going to go over to 14 and up 4. And I'm going to put a good solid point there. Okay. And then it says Tyrell at 25 feet scored 6. And so 25 is going to be over here in between this 24 and 26. And then I'll go all the way up to 5 points and put a solid point there. Anthony at 27 feet, again, that's going to be between 26 and 28, scored 7. So I'll go all the way up to 7, give him a solid point there. Mark at 15 feet, which will be between the 14 and the 16, scored 11. So we're going to go up to 11, make sure we're in between the 14 and the 16, and we're going to give Mark his point here. Then CJ scored 6 goals at 26 feet. And we've got a 26 axis here. We'll go all the way up to 6. Give him a point. Kevin at 16 feet scored 13 goals. So we'll have to go up pretty high and give him a point. Wade at 15 feet scored 12 goals. That'll be in between 14 and 15. We're going to go up and put a point at 12. Very good. Kyle at 26 feet scored 8 goals. Chris at 16 feet scored 14 goals, so that'll be all the way up here at the top, and my X should be at 16. And then Tim at 28 feet scored 5 goals. Very good. So number 1 says, what type of association do you see in the scatter plot? List any observations in the space below. So if you notice, if we were moving from left to right, okay, I'd be up here and I'd have a lot of goals whenever I was closer to the basket, right? Because 16 feet is going to be closer than 28 feet. So at 16 feet, I'm standing a little bit closer to the basket and I'm able to score more goals. And then you can kind of see this trend line going down. As I move further away from the basket, the amount that I can score is going to go down. Okay, so since this is going down, we're going to say that it is a negative association. Okay, and then I'm also going to put a box here around this 14-4, okay, Jared's point, because you can notice that his is not really clustered with any of the other team members. And so he's kind of like this outlier, this outlying point, okay? So now we're going to scroll down a little bit, and we're going to see if we can answer these true-false questions here at number 2. It says, use the scatter plot to label each statement as true or false. We'll just use T and F. We don't have to write out everything. It says, as the distance from the goal increases, the number of baskets decreases. So our x-axis is going to be that distance from the goal. So as that distance is increasing, what's happening to the number of baskets that they score? They're going down. So this is going to be true, right? They can score less as they get further away. As the distance from the goal decreases, the number of baskets made is increasing. So here, when they're standing closer to the goal, they're making more baskets up here. So that's also going to be true. Okay. C, as the distance from the goal decreases, the number of baskets made decreases. So what they're saying is, say the goal is over here at 0, 0. As I start walking closer to the goal, is the number of baskets that they're making decreasing or getting smaller? Absolutely not. It's getting larger. So we're going to put false. That would be a false statement. Very good. So now we're going to fill in our notes. It says outliers. A point that does not fit the overall pattern or trend of a scatter plot is known as a outlier. So over here in our notes, we're going to put pattern. Okay, and then I'm going to go back up and we're going to talk about that. It says, who was the outlier in the scatter plot above? And remember, I had you box in Jared's point because he wasn't clustered with the rest of the data and he was kind of way out here by himself. Remember that? So Jared is going to be our outlier. So we'll write Jared here. Oh, I lost my point. Okay, sorry, I had a technical difficulty. I lost my ability to draw on the OneNote. Anyway, so we're going to finish writing Jared's name. Okay. And then that explanation is because his point was not with the other ones in the trend. Or we could say his point did not follow the trend. Okay. Clustering, it says clustering occurs in a scatter plot when there are distinct or separate groups of points. So over here we can write groups. Why do you think the clustering occurred in the scatter plot above? Okay, so let's go ahead and scroll back up here and see if we can see and determine these 2 points. Okay, so we've got a cluster here at 14 feet, and we've got another cluster at 28 feet. Okay, and if you notice, we have 1, 2, 3, 4, 5 clustered out here, and then we have 1, 2, 3, 4, 5 kind of clustered back here at the back. And so what it could look like is half of the team shot points at a far distance away from the goal, and then the other half shot closer to the goal, and then Jared was our outlier because he was still shooting close to the goal, but he wasn't a very good shot. He missed most of his shots, and so he would become our outlier. So why do we think that the clustering occurred in the scatter plot? Because the team was split when they shot the goals. Very good. Okay, and so just from this graph up here, we can determine several things. As we get further away from the goal, we can make less of our shots, right? As we walk closer to the goal, we make more shots. And then we can even see kind of what was happening whenever they were collecting their data. Half the team shot far away, half the team shot close. And then we can also tell that these other group of guys are pretty consistent, but Jared might want to go practice a little bit more because even though he was standing close to the goal, he was our outlier because he didn't make very many shots. Okay? Very good. So now we're going to move on to the second page. So if you're following along, take a second and flip over to the back of this first handout. It says the population of 10 cities and the number of elementary schools it has is shown in the table. And we're going to make a scatter plot of the data. So all we're doing is simply graphing it. And here it's given us our axis, our x-axis and our y-axis. They're already labeled. But I'm going to go ahead and come down here and make sure that I put that this horizontal axis is my x-axis and the vertical axis is my y. We know that our x is going to represent population, and then our y is going to represent the number of elementary schools because they're labeled for us. So that's going to be very important when we go to graph it. The city of Lawton, very close to my last name, pretty cool, has a population of 76,000. And it has 19 elementary schools. So what we're going to do is we'll come over here, and at 76,000, now you're probably thinking, Mr. Lawson, you've lost your mind. That says 70, but over here in parentheses it says thousands. So this would be 70,000. And we know that 76,000, they're counting by tens here. They just skipped one, so we could say that this is 80. So 76,000 is going to fall somewhere between 70 and 80, and then they had 19 schools, which would be between 18 and 20, so we'll put a dot here at 76, okay? And then Moore, the city of Moore, like Miss Moore from the 7th grade, has a population of 60,000, which would be in between 50 and 70, and then they have 17 elementary schools, so we'll give them a point between 16 and 18 at 60,000. Lufkin at 35,000 has 10. So we're in between the 30 and the 40. We'll put 10. Again, they're counting by 10, so that'd be 30, 40, 50 if you're confused where I'm getting those numbers. Cheyenne at 73,000. That'll be here in between the 70 and 75 that we marked earlier. They have 22 schools. So at 73, we'll shoot up here to 22 schools and give them a point. Danville at 51,000, we'll put it very close to this 50,000 mark, has 13 schools, which will be between 12 and 14. Madeira at 78,000, which will be over here really close to the 80,000, has 26 schools, so I'll come up to the 26 and plot a point on that line. Very good. Weatherford at 25,000. So over here between this 20 and the 30 at 25,000, I'm going to go up and put a point at 12. Very good. Prosper at 13,000, we'll be down here between the 10 and the 15, okay, is going to have 7. So we'll go up between the 6 and the 8 and put our point at 7. Glens Falls at 20,000 is going to have a whopping 20 elementary schools. And then Dalton at 85,000 is going to have 21. Very good. And then it says, describe any association between the variables. What conclusions can we make? So again, we're going to want to draw a line, and we haven't talked about trend lines yet. That's going to be in the next couple of lessons. But if we draw a line in between our data as best as we can, going from left to right, this data seems to be showing a positive association. Because if you remember when we were talking about slope, if I was going to be a little man walking up this line, I would have to walk uphill. And if the data is increasing from left to right, that's going to be a positive slope. And so since this data is increasing from left to right, we're going to say that it is a positive association. So down here at 4, we'll put positive association. Okay. And then I want you to take a second. I'm going to quit talking so you can pause the video and maybe look at the data and see if you can pick out the outlier. Okay, so if we look up here, there's this point that's kind of hanging out here all by itself. And I'm going to box it in because I'm going to say, hey, that's kind of weird. Why is this point hanging out? And it's not really clustered with the rest of these points in the trend line. Why is that? Well, that's going to be an outlier. And then I can go back and say, okay, I'm looking for a school that's at 20,000 and it has about 20 elementary schools, and that was Glens Falls. So that's going to make me think, if they ask me a question about an outlier, I might be wanting to look for Glens Falls, okay? And then, whoa, if we look at number 5, it says, are there any outliers in the data? It's kind of like I knew they were going to ask that question. Pretty interesting. So, again, we boxed in Glens Falls. We know that that's going to be our outlier. So, I'm going to write in Glens Falls here. And then you could put, they did not follow the trend. Okay, and then are there any clusterings? I'll scroll back up, that way you can see the graph again. There's really not. Going from left to right, if we're looking up here, the data is pretty spread out. They're not really clustered, so we're going to go ahead and say no, there is no clustering. Okay, now we're going to go ahead and move on. Scroll down. It says on Tuesday after school, Charlie asked 9 different students how much money they had in their lunch account, as well as how many homework assignments they had that evening. Use the data he collected to make a scatter plot. Okay, so again, they've already gone ahead and labeled our axes for us. So this x-axis is the amount in their lunch account, and the y-axis is going to be the homework assignments that they have. And then the homework assignments was our y, the lunch account was x, okay? So I'm going to go over $8.24 for this first student. And then it said they had 0 homework assignments, so I don't have to go up any on my y-axis, and I'll put a point there. Okay? The amount in the lunch account for the second student was $29.05. He needs to bring a letter home to his mom so she'll go pay his lunch account. And they have 2 homework assignments. So up here right in front of the 30 is where 29 would lie. I'm going to go up to 2 homework assignments and put a point. The third student at $4.75 has one homework assignment. That'll be just before $5, and I'll put a point there. Our fourth student at $20 and a penny has 0 homework assignments, so I'm going to put a point right at the 20. It'll be close enough to 2001. Our fifth student at $1.80 has 3, so just right here in front of $1, I'm going to go up and put something right before 2. Give me a good point here. Our sixth student at $11.92, almost 12, okay, is going to have 4 assignments. So I'm going to put a point here. Very good. And then our 7th student has no charges on his lunch account, and he has 1 homework assignment. So I'm not going to go anywhere on my x-axis, and I'll go up to 1 and put a point. Okay, $17.50 for my next student. So that'll be in between the 15 and the 20, a little bit closer to the 15, maybe right there in the middle. And we're going to go up to 2, and we're going to put us a happy little point. Shout out to Bob Ross there. And then our last student at $26.11, right in front of this, or right behind this 25, I'm going to go up to 3 and put a point. Okay. It says, describe the association between the variables. What can we conclude from this? So if I'm looking over here from left to right, does it look like I have any sort of trend happening? Not at all. I couldn't go up, I couldn't go down. These points are just very, very scattered along this graph. So I'm going to go ahead and say that there is no association. Okay. Are there any outliers? Well, there's not a line for us to look at to see if there's any points that fall, really far away from that line. So we're going to just say no, there's not going to be any outliers. And then are there any clusters? I mean, you could say that there's a cluster of these 3 students over here, but just 3 little students with their lunch account and things like that. I'm going to go ahead and say that there's no clustering either. Okay. So if you have some questions, I think what's going to kind of stop us up the most, and what I think we're going to need a little bit more practice on, is taking a table and graphing the points. And so if you need a little bit more help with that, if you feel like you're struggling with it, let me know, and I can find some IXL assignments. I could make a tutorial video to kind of help you get a better grasp on that. But really, if you can understand how to graph the points from a table, look at your scatter plot, see if there's a trend line moving positively from left to right or negatively from left to right, you'll be able to see your association. If we look back up here at this last scatter plot that we made, you can see the obvious outliers that are not moving with the trend. And then if you just kind of use just a tad bit of life experience and then a little smidgen of common sense, it all really makes a whole lot of sense. Because if we think about it, is the amount of money in your lunch account going to dictate how much homework I give you as a teacher? Absolutely not. So it makes sense that there's no association here, right? And then does it make sense that there's a positive association between the population and the amount of elementary schools? Absolutely, because the more people that you have in your city, the more children you have. The more children you have, the more elementary schools that you're going to need. So as the population increases, the number of elementary schools are going to increase. And then if you have any experience at all on the basketball court, as you move further away from the goal, it's a lot harder to make your shot, giving us a negative association. So this all kind of makes sense, and it's not too difficult. Again, if you have any questions, feel free to email me at dlawson@ssisd.net. Feel free to go through your homework. Email me any questions you might have. Go ahead and start working on that. If you will write at the top of your homework, right under here where it says unit and scatter plot, I'm going to write bonus. I don't want you to write bonus, but if you will take a second and you'll just write down that Mr. Lawson's favorite pet is his boxer named Rusty, I will give you an extra 5 points because I will know that you watched the video. Okay? So have a great day. I'm thankful that you took the time out of your day to study and watch this video. Um, have a good one.